My name is Aid. I work for a company called Gilt.com, and about a year ago I came to this conference, really loved it, and decided that we wanted to implement search on Gilt.com, which is really strange in this day and age to have a website that doesn't have search, right? Turned out that there was a lot of great challenges along the way, a lot of great stories, and I just wanted to share them with you. So it's really great to be here. The other thing is in the course of this presentation, I'm going to give 20 of you $25, okay? That got your attention, right? So keep an eye out. There's going to be an Easter egg in here at some point, right? And you'll have an opportunity to get some cash, okay? Sorry, well, not quite cash, credit. So this is me. I worked for Gilt.com for 2 years. Before that, I was a traveling consultant. Did quite a lot of travel all over the world. Based primarily in Ireland, that's where I live. And also along the way became a committer for the Apache Foundation. So that's me. The Gilt tech team, it's actually quite a global organization based out of New York with engineers in Portland and in Dublin and in Tokyo. Okay. So what is Gilt, right? In order to get a feeling for why this search thing at Gilt was hard, it's important to understand the Gilt business model, which is about flash sales, okay? So yeah, the key thing is exclusive, gorgeous stuff on sale at noon. There are low quantities, right? And there is a very large number of people rushing to the site to get the stuff, okay? The original Gilt concept was all about women's wear, okay? At noon, this isn't the women, this is a herd of buffalo. At noon we get this Stampede, and it's kind of, it's fully intentional, right? It's all about going insane and fevered about buying great product, okay? It was so successful, we then extended the business to a men's business. We also then extended it to baby and kids, which is also very good for us. And then for homewares and design stuff, I led the team that built that site. Then taste some of the most amazing food that you can get, and then city deals, right, which is just absolutely incredible things that you can do in your city, and then travel deals as well, right? So really high-end product, okay? And like I say, the whole thing is predicated on this kind of attack of self-denial, right? So at noon we get a ton of people just hammering at the site. This is kind of indicative of the kind of traffic that we get. So kind of low, before noon, and then at around a quarter to noon, we send out all our emails and our push notifications to all of our members, and then all of a sudden they come at the site like crazy. Okay, so yeah, absolutely. Okay, so what's the problem, and why is it hard? Okay, so first to talk about the Gilt data model, right, and kind of just to elaborate on some of the things that make Gilt different. Okay. So it's a classic kind of retail data model. This is just the smallest subset of it that is interesting. So we've got these things, products, right? So for example, the silk charmeuse wrap dress. Every product has a number of looks. Typically, look just means the color, okay? And as we'll see later, color actually proved to be incredibly difficult. And then for every look, for example, we've got the dress in white. We have SKUs, stock keeping units, okay? And at the SKU level, that's really where you've defined something that you can buy. And typically the big thing on the SKU level is size, okay? So we've got tons and tons of SKUs, and then basically every SKU can be involved in a number of sales, and every sale can have a multiple SKUs. Okay, so we've got as you would expect, a strongly relational kind of model, right? And the thing is, when it comes to Solr, one of the first things kind of that smacked me across the face was Solr doesn't do relationships very well at all, right? And it was one of the big kind of design problems for us. It was like, what exactly is the right kind of thing that we should be indexing? Should we index everything here, right? Or should we just index at the product level or at the SKU level? How's it all going to work, right? And there was a lot of very difficult kind of issues kind of came out there, okay? I was prompted to write a haiku on the issue. I write a haiku once every decade, so that was the one for this decade. So the overall solution, I just wanted to kind of give you an idea of what it looks like, right? There's a couple of things that were kind of really important in terms of how we put the solution together. So at the far right, you can see Solr, right? We've got a few instances of Solr. It's not a massive deployment of Solr. But what's key to this solution is that we had to write a bunch of plugins and a bunch of components that fitted into Solr to basically handle our data and to handle some of the kind of more delicate things about the search problem. Okay, so that's on the far right. Now, the other thing then that was interesting was, we're indexing all of this content, all of these products that we have, okay? But we're not actually storing any of the information inside Solr, right? We took an architectural decision that Solr should just give us the list of products and SKUs that are relevant, okay? And what we do is once we have that list, we then hydrate that with real data, right? And the reason behind that was we only wanted Solr to do one thing and one thing well. Okay, we didn't want to have part of our data model lost inside Solr and another part of our data model kind of defined somewhere else. Like we already have enough of that at Gilt, so we wanted to make sure that we just kept it really, really simple. Okay, so then in front of Solr we have a Play app. At Gilt we're using Scala quite a lot, and Play Framework turns out to be really, really good. So we have a Scala/Java based API that we use to kind of insulate ourselves from the details of Solr, and then all of the app itself then I guess is just all in Play Framework. Okay, the whole solution took about I think 4,000 lines of CSS, HTML, what else? A little bit of JavaScript, some JavaScript, and then some Scala, right? But it was a really, really small solution at the end of the day. Like I said, less than 4,000 lines of code. Okay. So let's talk about the search space. Okay, what did we index and how do we look at this problem, right? So the first thing I did was I said, right, let's draw some boxes on our product detail page and see what could be interesting. Okay, and some things come to mind. Obviously, the product name, the product brand, the price has to be indexed. What else? The taxonomy, where it is inside our product taxonomy. Okay, the color. Very interesting. We want to have people able to search for black dress, for example, or red shoes. Description, which we thought was a really obvious thing to do. You couldn't go wrong indexing on description. And then there's other things, that, for example, a chair might have. We call them SKU attributes. So, for example, it's in leather. The finish is chrome. There's a whole bunch of things there about the SKU. So naively, we tried to index everything, okay? And we ended up kind of having one hell of a time in those early days as we learned more and more about our data and about how crappy most of our data is, okay? And I sense that we're not unique in this, right? We have data coming from lots of merchants, from lots of vendors that's coming into our system and actually can lead to some really, really bad results. Okay, so what kind of things went wrong? So first thing, for example, the description, which we thought would be a perfect place for indexing, right? The description would have very distracting tokens. For example, the merchant would have written also available in blue, black, green, and leather, right? So if you're searching for this particular SKU, right, and you want the red one, right, you could also get green and black and all sorts of things thrown in as well. Okay. The other thing we found was that colors were often really poorly classified and really named, right? You think that black is just black, right? But it turns out actually there's any number of different ways that black could have been written down, right? So as you can see, black, priest, black, white, knight, 100, whatever, all these things, right? The other thing is that the brand names themselves can mislead, right? We have Red Carter is a brand name, so you do a search for a black dress, and the first thing a red dress, and the first thing you see is a black dress, right? Because you've got Red Carter in the name, right? Thomas pink shirts is there, white and Warren black dress. It turns out that this is the kind of edge case that you think isn't really going to bother you, and then literally the first time you run a color-based search, it just smacks you across the face. Okay, so in the end, we were able to solve a number of these problems, and for example, we just stopped indexing on description, for example, because we figured actually it's just a total distraction, right? We put a lot of effort into fixing the color issue as well, and I'll talk about how we did that. Okay. In terms of surprises, one of our first prototypes was a complete, disaster. The Solr query tool is very helpful actually in terms of actually debugging what the hell went wrong here. Okay, so what we did was we said synonyms are good. What we'll do is we'll use the Princeton synonym database, right, and we'll wire that through so that basically we'll have be able to get the most relevant results, right. a black dress gave us this Raspberry Jet Set tote, right? And obviously we were confused. And it turned out actually then, so basically black synonyms to jet black, dress synonyms to the verbs to set, to dress to set, right? And so that's how we ended up with this kind of crazy search result. Okay, so so like I say, this was very, very interesting in terms of getting into the data and kind of seeing the things, you know, that could go wrong. Okay, so now the next question then was what are we going to index? Are we going to index products, looks, or SKUs? Okay, so what we want to list, the results that we want are product looks. You know, here is the dress in red, or here is the dress in black, or whatever. Okay. So we thought you could index the looks. The thing is, though, size is hugely important in retail, right? So we were thinking, well, okay, we could put size in as a multi-valued field, okay? And that seems really, really good, right? But then you have to realize that our business model has a very sparse set of inventory, right? Sparse, okay? So for example, if I do a search for a pair of shoes in size 13, okay, and I find them and I go fantastic, and I click on them and it takes me to a page that says we're sold out in size 13. You know, the size exists, but we don't have it. Okay, that's disappointing. Okay, so then I try it again and I click on another set of shoes and it also exists in my size, but we don't have it. Right? At this point, you've disappointed the customer twice. Right? If there's still a stain on your site, then you know it's just insane. I mean, like, yeah, you do not want that to happen. Okay. So the solution we had was to denormalize, right? So we actually said, why don't we stop indexing looks and index at the SKU level, right? And that basically means then that every SKU just has one field for size, right? And then filtering and faceting on that works a treat, okay? The problem, of course, and we labored over this, is but we have all these SKUs coming back now, but we don't want to show all of the SKUs. Like, we don't want to show a listing with 7 pictures of the same red dress just because each one has a different size, right? So we needed a way to group them. And this is something that we obsessed about. We were really, really worried whether the grouping algorithms in Solr would actually cut the mustard, whether they'd be able to do what we needed fast enough, okay? So it turned out we just said, listen, okay, Solr has this grouping function, let's actually just use it. So what we do is we take all the SKUs and we group them by the product's look ID, right? And it turns out that this performs really, really well. Okay, we found absolutely no problems with the grouping mechanism in Solr. Super fast. So that was very, very good. Okay, we toyed with the idea of changing to block join queries in Solr 4, but it turns out actually we've never had to go any further. Okay, the existing grouping mechanism works absolutely fine. And there's just some notes in terms of how we do that. Okay, so I'm going to build up this diagram here. This is effectively the internals and extensions that we built, right? So the first thing is we've got an index. We're indexing SKUs. And on the right now, or over here then, we're using this grouping algorithm, okay? And that's what groups everything together into the search result. Okay. So let's have a look at the next thing, which is inventory ordering, right? It turns out in e-commerce that what you have in the top left, right, is the thing that people read the most, right? So our merchant folk, when they have a sale listing, they're going to put all of their best product on the top left, right? Conversely, the best product is going to sell out super fast, okay? Which means that when people look at the page, let's say 3 minutes after noon, the first 12 items might be all sold out, right? There are very few users who are going to be as engaged enough to basically scroll down and find the stuff that's actually available, right? So what we needed was a way to say, okay, we need to, whenever something is sold out, we need to default to the very bottom of the search results, okay? And we need to move everything else up, okay? So that sounds easy, but the thing is that the inventory status is changing so fast. Like at noon, it's just an absolute barrage of data. You can't index that fast, okay? So we needed another way to augment the search results with real-time inventory status, okay? So how do we do that? Right, what we did was we implemented in Solr a custom inventory function, okay? And the inventory function just returns a Boolean, right? So 0 if we don't have any inventory, and 1 if we do have inventory, okay? And then we sort on that function, okay? So what's happening then is we go, whenever we get a listing, we say order by inventory SKU and then the relevant score, right? And what that does is it pushes all of the sold out stuff to the bottom, okay? So very pleased with that. That made our plugin architecture a little bit more complex, okay? So it looks a little bit like this, okay? We've got all the stuff in the index on the right. We've got, when it comes out, we add or we score each one with the inventory function. Then we sort, and then we group, okay? And that turns out to be super fast. Now, one of the reasons why it's super fast is that the actual inventory status for all of our live inventory is cached now inside of Solr. Okay, it's cached inside this runtime. And that means that any time that we need to say, hey, do we have any of this stuff available? It's already in memory for us to use. Okay, it would be suicide to try and hit an external inventory service for every product that we're trying to filter. Okay, so no performance suicide. Okay, so then targeting and personalization. So this is where things started getting kind of really interesting. So in Gilt, we have these idea of sales. Some sales are targeted, right? This means that you as a particular user are allowed to see this product, maybe because you're a special user, or maybe because you live in Portland and it rains a lot, so we've got a sale on rain gear, right? And we want you to see that sale, okay? So the idea is that when we have something like a targeted sale, if you're allowed to see it, then you should also find the products in that sale in your search results. Okay, so that you have a consistent experience, okay? And likewise, if you're not allowed to see a particular product, right, then you shouldn't be allowed to see it in your search results, right? So we had to make sure that that Solr respected the what's the word? The access rules, if you will, for product. So how did we do that? Okay, let me see. So what we did was, right, we stored the sale ID on every SKU. So for everything that we have, we say the reason why it's available is because it's in this sale, right? And then for every request to Solr, we pass in the user's GUID, okay? That allows us then to filter, so Solr then has information on who the current user is, and then we had like a filtering interceptor here that basically says, is the user allowed to see this product, right? So, is the user, we would look at their GeoIP rules, or we'd look at set membership, have they been on the site over the last few days? Are they a new customer? All of those rules would start to kick in, okay? So we had a custom filter there, okay? And so then basically we end up with this, another custom filter there, right? So results come through, we filter out the ones that you're not allowed to see, we then add the inventory stuff, then we sort them, then we group them, and then you get the results, okay? So you can see we're building up quite a lot of complexity into the chain here, right? But it turns out, it just worked really great. Now, timing is everything. Gilt is entirely time sensitive, right? A product must become available at noon, okay? And when the sale is over, the product must not be available anymore, right? This is really important for our business model and really important for our brands, right? Because they'll give us some of their amazing product to sell to our members, specifically because we have a very dedicated group of members and because we're only going to sell within a limited time period, okay? And so we need to make sure that we get this exactly spot on, right? Now, we can't index Solr fast enough in terms of, you could say, well, maybe, basically at a second before noon, just re-index everything and show all the product that's available, right? So basically, we can't index fast enough. Currently, we're doing an index every 15 minutes. We could do every 1 minute, but basically, the length of the index is irrelevant. We needed this to be pinpoint accuracy, okay? So we needed to encode a sense of time in the index, right? So what I want to describe here is in a sense, our initial solution, some things that we learned, right? And then how we eventually came to our final solution, right? So the first idea was to say, let's actually store the start time and the end time and the sale that this thing is available on, right? So this product is available at this time. It won't be available after this time. And the sale that it's available in is this particular sale ID, okay? And then we thought, well, that's great. We've got the information on the products there, right, on the timing. So then we just use a filter query, right? So we'll be able to say, I'm looking for products, and by the way, it must be in the following time bound, okay? And of course, Solr does filter queries really well, all fantastic. The only thing about this is that obviously the time now is the current millisecond, right? And that means then that Solr wouldn't be able to cache any of these filters, Okay, so we were then in fear. Is Solr going to simply fall over? Okay, like we won't have any query filter caching. The whole thing is going to go terrible. Okay. And then I went to the conference last year and I attempted the great Stump the Chump session, and I basically got in with one of the first questions, right? And I kind of expected that there would be a really, really long, crazy, and undefinitive answer to my problem, right? Of how to effectively cache time-based queries, right? And it turned out Haas basically says, oh, it's dead easy, right? All you do is round down now to the nearest minute or the nearest hour, right? And if you do that, then basically all queries within the same time range, be it the minute or the hour, will round down to the same value. So you'll have a really nice query filter that Solr can cache at ease. Okay? So it turns out that this little insight basically saved our bacon, right? This was just a super, incredible solution to make sure that we could get super time-sensitive stuff done really, really well. Okay, so we love the Chump. If you have any questions, go to the Chump session. It's absolutely brilliant and learn a lot. We got a lot of champagne and caviar out of that one. Okay, so time-sensitive search. So then we ended up with these kind of dynamic fields that in the home store, this SKU is available at this time, at this end, and then in this sale. So we stored all of these dynamic fields inside Solr. Okay, worked well. We hadn't launched to production yet. We actually started hitting some kind of crazy things, right? We were trying to figure out why the hell is this stuff not working the way we thought it was going to work. And it turned out that the edge cases that we thought would never happen were immediately kicking us, right? It really was a case of, like, in the design session, we were like, nah, that'll never happen, right? And then day one, bang, right? So the problem is that SKUs can be active in more than one sale, if you remember the data model from the start, okay? And that means then our schema only says, well, this SKU is in one sale, okay, per store. And so we had to say, well, what heuristic should we use in terms of deciding which sale this thing is actually live in, what the customer should see? And we basically said, we'll pick the first active availability window, okay? And where that can smack you then is say, well, imagine the product is available here in sale A, and it's only available to 5% of our users, right, the noir users, okay? And then the problem is that the product goes live to everybody in another sale. And in this overlap period, the folks who aren't noir won't be able to see the product because the sale targeting will exclude them from seeing the product, right? So smack across the face. This is the danger zone. Turned out to be very, very tricky. And it was one of those moments in a project where you think, we're screwed. There's no way this is ever going to work, okay? And then we discovered that it was even more complicated than that because we have different sales that are targeted to different devices, right? You might be coming in the web or you might be coming in on Android, right? And we basically want to target stuff to encourage people to use their phone, right? And to sign up using their phone. We ended up saying, well, if we keep on going the way we're going to end up with the Cartesian product of the channels by the stores, and this is all going to get really, really horrible, right? And then, so we just had this Eureka moment, right? And again, it's back to denormalization, right? We basically said, let's stop indexing SKUs, right? But let's index the availability of a SKU at a moment in time. Right? This is space and time together, right? And all of a sudden, right, code started falling away, right? It was a moment of absolute brilliance. The schema just became super simple, right? This SKU is available at this time and available at this end, right? It's available in these stores, whatever, right? Our queries became so much simpler as well. We didn't have to encode things like the store that you're coming in on or the channel that you're coming in on, right? The only problem with the solution is clearly that you're going to end up with duplicates, right? If the SKU is available in 3 different sales and you search for it, then you're going to get the SKU back 3 times, okay? So what we had to do was implement a filter as a plugin, right, that basically removed duplicates from results, okay? So hence, we're nearly done with the architecture. Hence, we ended up with this additional filter here, which is our deduplication filter, okay? And we also wrote then this availability component up here. The idea of the availability component up on top here was really just to make it really simple. Like those filter queries were actually really complicated, right? And you didn't want to have, if somebody was playing with Solr, we didn't want to have people having to type those filter queries in themselves. Okay, so we made it really easy. The availability component calculates what the correct filter should be, applies them to the flow, and then away we go. Okay, brilliant. Okay, so I think there's one more or a couple more areas. Oh yeah, faceting, right? So faceting in Solr is great. Okay, and there's a lot of very cool things that you can do with faceting, right? But there are also many ways that the faceting solution really sucks. Okay, so one of the things that we tried to do that we felt was very good was we wanted to be able to say multi-select faceting was really good. So I should be able to select, I'm looking for all the shoes in size 13 or size 13 and a half. I'm easy, right? So you want to be able to multi-select, right? But the other thing is we wanted to be able to mix the logic. So you can see here, I'm interested, when I'm in the same facet like size, right, I use an or. I'm interested in size 13 or size 14, right? And then I want the brand to be Timber Island or something like that, okay? And the color should be red or the color should be blue. So in the same facet you use or, and then across the facets you use and, okay? So that's how we implemented the logic, and that uses the multi-select faceting technique. Worked out really well, right? The only problem with it is we ended up with the disappearing facet problem. Right? It's very subtle. We lost a few days on this. Basically what happens is when best done by an example, right? We basically set the facet min count to 1 because we're only interested in relevant facets, facets with more than one result. However, subsequent queries can end up reducing that to 0, so that means they disappear. So here's a great way of looking at it. You search for shoes and you get 10 from Aid and 5 from Eric, 8 black and 7 red, okay? Then you filter on red, right? And then you assume that only Aid has red shoes. You end up, what you want to have is this: brands equals Aid 7, Eric 0, colors equals 0, red equals 7. But what you actually get is this, right? In other words, the fact that Eric brand is relevant to the original query is lost, okay? And this created a problem for our front end, right? Because basically it meant that there's a state issue. The client has to remember the fact that Eric is relevant, okay? And we wanted each call to be really stateless, okay? We came up with a solution to that, and so for each facet we added an extra facet field, the all brand facets or the all color facets. And then when we get all the facets back, we overlay them so that we can tell, well, Eric was relevant, and there are now 0 due to subsequent filters that have been applied, okay? This is really horrible, right? I think this is one of the cases where we said, it shouldn't be this way, and it's one of the things definitely that I would absolutely love to fix, okay? Turns out that color, I got this on the web. It's absolutely fantastic. I'm a very simple guy. I know what pink is, right? I don't know what carnation is, right? And even magenta I have real trouble with, right? And salmon, right? In fact, everything on the left-hand side there, right, I have serious problems with. It turns out that women have a far greater appreciation of color maybe than men. I hope that's not too wide a generalization. And it turns out that merchants in the fashion industry, maybe they're all women, I'm not sure, but they all basically like to use very exotic colors, right? So I'm like, why can't you just call it yellow? Why did you call it urobilin, right? Right? And ultimately, people don't facet on urobilin, right? They facet on yellow. So we're trying to figure out, what's the best way that we can clean up our color data, right? And effectively, what we ended up doing was we built a mapping file that mapped all of these crazy colors into the men's color on the right-hand side, the easy color, right? Right? And then what we did was, if we got any unknown colors, we just removed them. Okay, so because you end up with a bunch of very kind of weird kind of colors at the end. Okay, and that basically allows us to build a faceting model that just has the plain colors. Okay, and that actually works out reasonably well, okay? It's not a perfect solution, okay? A far better solution would actually be to completely ignore whatever somebody tells you the color is, right? And do some kind of analysis, color-based analysis on the swatch, right, of the product, right? Because that will actually give you a much better idea in terms of what the true color is, okay? So we got the color sorted out in the end, but again, like that was it was non-trivial, and it was an awful lot of, you type in a color like orange and you start getting something that's black and you wonder what the hell is going on, right? So that took a lot of work, okay? The other thing is our taxonomy is really important. So what's turned out to be very interesting is that people, when they filter, the biggest filters and the biggest searches are actually on brand, okay? And also on taxonomy. Okay, and it's a real mix between the both. So the thing is, our taxonomy is hierarchical. For example, we have Gilt and then men and then clothing and then pants, right? But Solr doesn't really support this kind of hierarchy in any way, right? So the thing is, you've got to abuse the system, right, and create your own kind of path-like taxonomy. So I used a double colon separator here. So that's the pants, the men's pants taxonomy. Okay, so this is not great, okay? Number one, it feels wrong. I kind of feel there should be a much more clever solution to this. I think that facet pivoting might actually be an answer to this, but facet pivoting is complex in its own right, in my mind. The other thing is that the ordering is always alphabetic, right? And that's a problem, right? Because people see the top left first, and what you want is your most exciting content to be in the top left. Do you know what I mean? So having an alphabetical ordering actually violates that, okay? So we didn't order our taxonomies, but where we did have to order or insert an ordering was on sizes, because we faceted on size as well, right? And if you think about it, size ordering is non-trivial because you want to see 000, 2, 4, 6, 8, 10, 12 rather than 0, 0, 0, 10, 12, 2, 4, 6, 8. Right? Likewise, for t-shirt sizes, right, it's all a jumble, right? So in order to get the sizes done right, we had to encode an ordinal inside the hierarchy, right? Really feels hacky, right? It really feels hacky. Now listen, it works very well. But ultimately you kind of feel, maybe this is the issue, that you kind of feel that you're having to solve hard problems. Solr starts out being super easy, and then all of a sudden you hit a couple of roadblocks along the way, So this is the final solution. Solr internals and extensions 5. Basically, here's all of the plugins that we wrote, and they all basically are in process with Solr. Okay. I know it's good at this conference to boast about how big your deployment is. Our deployment that powers search on Gilt is actually alarmingly small. It's actually great. We have 3 instances of Solr. Solr 3. They're in a master-slave configuration, and then we have 3 instances of Play Framework in front of those, right, and a load balancer across them, and basically that's it, right? So that's actually great. I mean, we didn't have to deploy 64 or any other power of 2 number of machines in order to get this all to work, right? Now that said, we will scale it up because as our product set increases, there's some other problems that we know we're going to hit. But right now, this turns out to be really good. Okay, so lesson number 1, right? Solr makes you happy. This is a picture of us on launch date when we launched it. The team, about I think between 6 people, maybe 7 people along the way, did it all in about 3 or 4 months, right? And that was, a fantastic achievement. And like I say, in less than 4,000 lines of code, we got through quite a lot of stuff, right? So yeah, and I kind of joke. I mean, the words, "Solr, you bitch," were uttered more than once, right? However, the aggregate outcome, right, was goodness. Okay, so that's great, and like you see, some very happy people there. So that was fantastic. Okay. The other thing that was really interesting is the business who were really nervous and skeptical about search turned out they absolutely loved it. Well, we knew they'd love it, okay? But there was in Gilt a very long tradition of saying, it's all about curated, merchanted product. And so, why would people come here to search? I mean, they come to us because we know what's going to look fabulous on them, okay? So what we did was we were very careful. We said, right, let's release to A/B test to 30%. We battle tested the initial deployment, and we were able to do 180,000 over those 3 instances, 180,000 RPMs with a ratio of 5:1 of autocompletes to search, right? Which turns out that was a good guess, right? But it turns out that's actually in usage the amount of autocompletes to search requests. Okay, this is the real amazing thing, right? So the percentage of people who use search on the site is not massive, but those that do are 4 times more likely to buy. Right? I mean, that's absolutely incredible. That's shooting your conversion rate. You know, for this group of people who've come to the site looking for something, right? Conversion is much, much, much higher, right? So that was really, really good. And our A/B testing showed that, you know, between the error bounds, basically that we're incrementing our revenue by 2 to 4%, okay? Which is actually great. I mean, we're not doing any more business or anything. We're not buying any more product. We're just selling it better, right? And that was fantastic. So really, really pleased. And then, of course, the business pleads with us. Please just send it out to everybody because it looks so awesome. And then what we've done since then is we've iterated on it. Originally, we made our search box really subtle, so subtle that you could ignore it very easily. You mightn't even know that it was there, right? But once we discovered that our users really liked search, we made it big, we made it bold, we made it really, really easy to use. Okay, so that was great. Okay, and then lesson 3. I mean, so what we've done there is we've got a search solution in place now. The search solution performs amazingly well. It's given us great insight into what our customers are doing, what kind of things they want. It's been amazing to see, for example, even over Christmas time, how how search actually increases and the kind of things that people search for around gifting time. Very, very, very interesting things happen there. Okay, so what are we doing? Well, what we want to do is we want to power all of our listings at Gilt. We want to unify so that basically everything is using Solr and that everything uses the architecture that we've identified there, right? That means that no matter what way you come to a list of products, you'll always get the same experience, right? And I think that's going to be really interesting. For our kids business, we've actually added extra attributes so we can facet on, like age and gender, which are super important to families and people who are buying for kids. Okay, we're moving to Solr 4, and then also there's a whole bunch of hacks that we did along the way to get to production that we would love to reinvestigate and kind of open up. Okay, because I think there's definitely a feeling that we can do better and we can move faster. Okay. So that's it. Thank you very much. And the link there for any of you who want the $25 in credit is at the bottom there. Gilt.com, Lucene-revolution-2013. And thank you very much for coming. Appreciate it.